Look around you. Everything is in motion. A planet orbits its star. A city grows. Even your thoughts are a cascade of change. To make sense of this constant flux, we need a language calculus. Calculus is the mathematics of change, the tool behind spacecraft trajectories, weather predictions, and the smartphone in your hand. While we credit Newton and Leibniz, the story of calculus is much older. Its roots stretch back thousands of years, across continents and cultures, as people asked, how much grain can my silo hold? How large is my field? How can I measure the sun's path? These weren't just puzzles. They were matters of survival. The quest to answer them sparked a centuries-long relay of discovery, each culture adding a piece to the puzzle. Our ancestors, without computers or calculators, used their minds to grasp concepts of the infinite and the infinitesimal. They laid the groundwork for one of humanity's greatest achievements. The story of calculus is the story of us. So let's step into our ship of the imagination and travel back in time. Our first stop, the ancient river valleys, where practical problems demanded practical solutions. The people there didn't call it calculus, but in their efforts to measure, build, and predict, they took the first steps on a long road to the stars. They were the unsung pioneers, the first mathematicians of change. 4,000 years ago, the Nile's floods erased property lines, forcing Egyptians to measure and divide land anew. Scribes became masters of approximation, breaking irregular fields into triangles and rectangles, and even approximating the area of a circle with surprising accuracy. Their methods, dividing complex shapes into simpler parts, echo the core idea of calculus. Meanwhile, in Mesopotamia, Babylonians tracked planets using geometric shapes to represent changing positions over time by plotting Jupiter's movement and using trapezoids to estimate its displacement. They glimpsed the essence of integral calculus. These ancient mathematicians weren't thinking about limits or derivatives. Their world was tangible land, grain, bricks, and stars. Yet their practical solutions contained the seeds of calculus, summing infinite little pieces to make a whole grappling with change. They built a foundation with mud bricks and necessity, not abstract theory. Their work was the first whisper of a mathematical revolution. The journey had begun. Fast forward to 3rd century BCE Syracuse, where Archimedes transformed approximation into a rigorous art. He sought not just good answers, but exact ones, trapping values between bounds, ever narrowing the gap. His method for measuring a circle's circumference, using polygons with more and more sides, squeezed pi into an ever tighter range. This method of exhaustion is the ancestor of modern integration, slicing a shape into infinite pieces and summing them up. Archimedes used this logic to solve problems that would challenge mathematicians for millennia, like finding the area under a parabola or the volume of a sphere. He was thinking like a calculus master, wrestling with infinity, making slices infinitely thin to reach perfect answers. Without modern notation, his proofs were geometric and intricate, but the core idea, summing infinite slices, was all there. Archimedes built a mental lever powerful enough to move the mathematical world. But it would take centuries for humanity to be ready to use it. The journey continued. Archimedes' flame traveled east, carried along trade routes, as the story of calculus became a global relay. In India, mathematicians like Aryabhata and Madhava developed infinite series for sine and cosine, centuries before Europe. In the Islamic Golden Age, scholars like Ibn al-Haytham advanced methods for summing powers and finding volumes, crucial steps towards integration. In China, Liu Hui and Zhu Chongzhi refined the method of exhaustion and calculated pi with astonishing precision. Across continents, mathematicians tackled the same problems of change and infinity, each adding to a growing tapestry of ideas. The world was converging on the mathematics of change. For centuries, the ingredients of calculus were scattered: Greek geometry, Indian series, Islamic algebra. The puzzle pieces awaited a unifying vision. In the 17th century, Newton in England and Leibniz in Germany independently forged calculus into a single unified system. Newton, driven by physics, developed his method of fluxions to describe motion and gravity. Leibniz, fascinated by curves, created the notation we use today. Integral signs and didex. Both discovered the fundamental theorem of calculus. Differentiation and integration are two sides of the same coin. This was the grand unification, connecting centuries of scattered ideas into one coherent theory. Newton and Leibniz built on the shoulders of giants, stretching back to the Nile. Calculus was now a language for the universe. The age of modern science had begun. Why does calculus matter today? It's everywhere. Weather forecasts, computer graphics, and GPS all rely on calculus to model change and predict outcomes. Even your body is a calculus machine. Catching a ball, your brain solves differential equations without you knowing. Calculus powers safer cars, efficient airplanes, and medical breakthroughs. It helps ecologists protect species and engineers design bridges. All these capabilities grew from ancient seeds, measuring fields, tracking planets, finding areas. The abstract ideas of the past are now the concrete realities of our present. Calculus is the silent partner in modern life. Calculus isn't the work of a single genius. It's a cathedral built by countless hands over millennia. From Egyptian scribes to Archimedes, from Indian and Chinese scholars to Newton and Leibniz, each added to the structure. Science is a cumulative, collaborative enterprise, driven by curiosity across generations. When we learn calculus, we join a 4,000-year conversation, a language describing everything from galaxies to heartbeats. The next time you marvel at the world's complexity, remember the long chain of thinkers who made understanding possible. Their legacy is all around us, in equations and in the beauty of a world in motion. We are the heirs to their genius, and the story of mathematics is far from over.